We are ready to run a simulation and analyze its partial results so far. 26. On parameters, make sure you define 10,000 iterations for your simulation. Once you have defined 10,000 iterations, when you submit, DT Simulator will ask you whether you want to proceed to simulate. Confirm yes and proceed to simulate. DT Simulator will start running its simulation. When the simulation is over, the program will ask you whether you want to save the results of this simulation. In order to provide for a fast simulation, DT Simulator generates its simulation within memory arrays instead of directly placing its results on a data spreadsheet. With or without results being saved for the simulation, you will be able to generate charts and perform analysis right after any simulation is performed. If you want to explicitly save the results for posterior analysis, this will happen by saving. Otherwise, the results will not be permanently saved, and next time you reopen the file, you will have to perform another simulation. The Simulated Data button allows you to view the results of your very last saved simulation on an appearing spreadsheet called Data. You can hide this Data tab by clicking again on the Simulated Data button. You do not necessarily have to place your cursor on top of any cell for the simulation to be run specifically for that cell. In fact, DT Simulator is running a simulation for all the open cells, input and output variables present on all open workbooks on top of Excel at the moment the simulation starts. The more input variables you have open at the moment of the simulation starts, the longer it will take for the simulation to run. That is why it is important to close all workbooks that may be open and are not necessary for the model that is being simulated and analyzed. On the other hand, the choice of 10,000 iterations is just a recommendation. Any number of iterations can be defined from 1 to 50,000 iterations on the professional version and up to 1,000 on the student version. In general, the larger the number of iterations, the better the precision or convergence of the results, but also the longer time it takes the simulation to run. Achieving convergence or precision on your model becomes an ever-increasing demanding task as such convergence achievement behaves decreasingly on a non-linear fashion.